Okay, so uh, this lesson will be a lesson for, and let me try this out. Okay, so this lesson we will be looking at two-dimensional movement. But before we go into 2D movement, I would like to talk a little bit about 1D movement, what we already saw. So one-dimensional movement, we saw the one corresponding to uniformly accelerated straight motion, okay, or something like that. Uniformly accelerated, this is the key to what we will be talking about here. Uniformly accelerated means that the acceleration for this movement is constant. Okay, so acceleration for this type of movement is constant. And we saw an example for this movement in free fall. Okay? Free fall. Why can we say that free fall has constant acceleration? Well, because acceleration equals to 9.81 meters per second squared, which is, the acceleration due to gravity. Okay, so it's constant acceleration in free fall because we have gravity that is constantly trying to pull us down with this value. Okay, so now we have to look at two-dimensional movement. Okay, two-dimensional movement in contrast with one-dimensional movement integrates two movements. Here, let me put another color because this one's kind of boring. Let's try some green. So it has horizontal movement, horizontal, and vertical. Remember that in one-dimensional movement we could have both up or down, or left or right, or along any given plane, but only on one dimension. Now we will be having these two movements integrated into one. Okay, so horizontal movement is movement along the horizontal axis, so we could either have this type of movement, and vertical is movement along the vertical axis. Okay, so we will be looking at this type of movement, two-dimensional movement, with an example of uh, parabolic motion. We'll be focusing on this type of movement, parabolic motion. That means that if given a starting position, I throw something, that something will follow a parabolic path. Okay, so something like that. So let's call this y, let's call this x. Okay, this is 2D motion. Why? Because I'm moving vertically and I'm moving horizontally. For the parabolic motion, you're going to put red. So for parabolic motion, we will be making the same assumption as we did for one-dimensional movement for free fall. Okay, we will be making the same assumption, and this assumption is that we have no air resistance. Remember in our first video that we saw how the bowling ball and the feather fell? And if you take air resistance out of the equation, so there's no air resistance whatsoever, both of them will hit the ground exactly at the same point, right? Exactly at the same point in time. So T of the ball will be equal to T of the feather, right? So this is an idealization, okay? So this is only ideal if we don't have any air resistance. And this is what we'll be working with in our equations, okay? So that means, that in turn means, let me change for another color. This in turn means, okay, let's put this here. This in turn means that the only force that acts that acts on the object is gravity. Okay, so that is the idealization we will be uh, working with. This means that our ideal equations, so our equations will not be equal to reality. But since we will be working with a really small scale, so for example, if you are going to use these equations for your project, so for Monkey Hunter, whatever you calculate will not be reality. But you can uh, modify those equations or tweak the numbers so that it actually fits reality. For your project, for Monkey Hunter, you don't really have to worry that your equations are not reality because we're working in a really small scale. Besides, the projectile that you will be using will be a ball, right? With minimum air drag. So min air drag. And velocity and air drag, so that is proportional. Oh, sorry. That's not the symbol for proportional. Air drag is proportional to the velocity, I think squared, I don't remember. But the higher velocity, the more air drag you have. Okay, so since we will be working with really low velocities, then you won't have that much air drag. Therefore, your equations will be similar to reality. Okay, so you don't need to worry about this. Let's see. Let me put a new page so that we can start anew. Where was it? Okay, it's here in layers. Add new layer. Put this one. Okay, let's make this one visible. We're good. So in 2Dmotion, you guys must think that it's kind of hard to put equations for 2Dmotion, but that's not necessarily true. 2Dmotion can be split into two types of movement. 1D motion horizontally and 1D motion vertically. Okay, and we already know the equations for 1D motion, correct? We already know the equations for this. So we know the equations for this ones, and we know the equations for this ones, right? They are the same equations, actually. The only thing that we need to take into consideration here is that horizontal motion has no acceleration. Why do I say that horizontal motion has no acceleration? Because there are no forces acting on my projectile in the horizontal motion. Remember that I told you in the past slide, the only force that acts is gravity. And gravity only works downwards, okay? It only works in the vertical, okay? In the vertical component of my motion. So my horizontal motion has no acceleration. Therefore, A will be equal to 0. We will be using exactly the same equations, just that in this type of motion, the horizontal one, acceleration will be 0. In the vertical motion, we'll be using exactly the same equations that we used in the past topic. We'll have acceleration equal to 9.81 meters per second squared. Okay. The only problem, the only thing that we need to do to actually do these type of problems, we need to figure out that, well, not figure out, we need to break down two-dimensional movement into two one-dimensional movements. So 1 and 2. So we can analyze the problem in two parts separately. We can analyze first or second, however you want, the horizontal movement. Oh, horizontal movement. And then we can analyze the vertical movement. Okay, the horizontal movement. How can we analyze horizontal movement? Well, we'll have a horizontal velocity in the x direction. And the vertical movement we'll have to analyze with a velocity in the y direction. Um, how do we check these two types of velocities? Well, remember that velocity is a vector, right? So velocity, call this the velocity vector, right? And this velocity vector forms an angle with the horizontal, and it has a magnitude, right? So remember, our horizontal component of my velocity will be the magnitude cosine our angle, and the vertical component will be the magnitude sine of our angle. Okay, so that's basically what we have to do. Given a velocity vector, we need to break it down into its horizontal components, vertical components, okay? And then just simply use our equations, the ones that we already know and love. So for example, remember this one, let's call it y equals to 1/2 at squared plus voy times t plus y0. So if we're going to be using this position equation with our vertical uh, component of velocity, well, this thing here, it doesn't go there. So this thing will go here, and that is basically it. For our horizontal component, x equals to 1/2 the acceleration times the time squared plus vox times t plus x0. But since we don't have acceleration in the horizontal direction, all of this goes away. So we're left with x equals to vox times t plus x0. And that vox is this one right here. So this goes here. So in essence, it's very, very simple. We just need to break down our problem into two one-dimensional problems. Since we already know how to work with one-dimensional problems, then our two-dimensional problem, we can break it down into two one-dimensional problems. Okay, our horizontal movement, just to finish, our horizontal movement is, I'll put this in Spanish, movimiento rectilíneo uniforme, so straight line motion, straight line uniform motion, and our vertical movement will be movimiento rectilíneo uniformemente acelerado. Straight line motion, but with acceleration, uniform acceleration. So this thing right here indicates that there is no acceleration. So all of this thing cancels out because a is equal to 0. And this thing implies that we have straight line motion, but uniformly accelerated. So a equals constant. And that's it. And that's it. This is only the theory for this type of motion. So 2D motion will be broken down into two one-dimensional, let's call them problems. Okay? We will solve the horizontal movement, and we will solve the vertical movement. And that is it. So I'll just finish this tutorial right now. And in the next tutorial, we'll start looking at the equations, which it's going to be a redundant video because the equations are the same as the one-dimensional movement, but I'll just make another video for it. And on the third installment, we'll get to see a quick example. So thank you guys, and see you soon.